everybody, and welcome to another episode of One Universe News. I would eat another taco right now, but I just ate a whole bunch, so I think I'm good, so I won't become one of those giant sumo wrestlers or anything like that. Today in One Universe News, we'll be discussing the Earth's very own atmosphere and the elements in which consist of it. Come on, one and all, sit down, do whatever you want. Well, actually, don't do whatever you want, watch this video and learn all about the arts of chemistry. So, first, I'll start you off with a basic question that everybody knows. Why is the sky blue? Well, that's because of the fact that the visible light of the sun, appearing white to the color receptors of our eyes, is divided into 6 different colors: red, orange, yellow, green, cyan, and violet, before the sunlight, at a very short wavelength, is separated and is scattered in all directions of the Earth's atmosphere. This is done by the tiny molecules within the Earth's atmosphere, especially the molecule nitrogen, allowing it to be blue because it makes up 78% of our air. Because of how blue is in shorter wavelengths than all the other colors except for purple, which violet isn't counted too much due to how it's only at the edge of the entire area of light. When we get closer to the horizon, the blue wavelengths, scattered by atmospheric molecules, fades into a lighter blue or even a white, before entering into the color receptors of our own eyes. Yeah, unless if you actually didn't know the reasoning as to why the sky is blue, you probably wasn't expecting anything else other than it is caused by how the ocean is blue, reflecting to the sky. Or, because Gandalf and Harry Potter united and scattered their magic to make it blue. That's why. Okay, probably not the latter reasoning, but let's just go with it anyways. We'll definitely be heading back for a more in-depth explanation of that, but for now, in order to get to that point, we're going to have to go into the basics of the basics. So, another question in which scientists baffled over until the last 100 years came along was as to what our atmosphere is made up of in the first place. For one thing, you have to know that Earth's atmosphere is about 300 miles, or 480 kilometers, thick, yet most of it is within 10 miles, or 16 kilometers, of the surface. That's as to why most airplanes have people enclosed in them, or else they'll be flying like A basic formula is that air pressure decreases as altitude increases, thus having there be less oxygen to breathe with a thinner atmosphere the higher up you go from the surface. When it comes to the specific elements in our atmosphere, 78% includes nitrogen while 21% includes oxygen. Only 0.93% is argon while 0.038% is carbon dioxide. Both carbon dioxide and argon combined make up less than 1% of the atmosphere. The remaining amount that still remains empty is made up of water vapor and other gases in random, small amounts. Sorry guys, but you just don't have what it takes. Plus, if you didn't took up more of the atmosphere, we may have a world like Mars and would all be dead fossils by now. Now, coming onto our own atmosphere within itself, you can actually say so well that the atmosphere is made all up of just one big layer. In fact, it's divided into 5 different main layers, with various sublayers in which we don't really need to mention. Not because I'm lazy or anything like that. This includes the Troposphere, the Stratosphere, the Mesosphere, the Thermosphere, and the Exosphere. The Troposphere is the layer closest to the Earth's surface and contains half of the Earth's atmosphere, being gravity within itself. It happens to be 4 to 12 miles, or 7 to 20 kilometers, thick. Air is usually warmer near the ground, but as altitude rises, it often gets cooler. Most of the water vapor and dust of Earth's atmosphere is found in the Troposphere, hence as to why clouds are formed here. The second closest layer is the Stratosphere. From the point the Troposphere ends, it begins and ends about 31 miles, or 50 kilometers, from the ground. Ozone, which is 3 oxygen atoms formed into one compound, is very abundant, heating up the atmosphere while also absorbing harmful UV rays from the sun. The air here is usually extremely dry, and, compared to sea level, it's 1,000 times thinner here. Due to such, it's where the jet aircrafts and weather balloons fly. Right there in the middle is where all of our meteors usually reach their fiery death, a place known as the Mesosphere. Not to be mixed up with the Mesosphere where everything else meets their fiery death inside the Earth's mantle. It starts up 31 miles above the Earth's surface, which is 50 kilometers up, and extends to 53 miles, or 85 kilometers, high. The mesopause, highest part of the Mesosphere, is the coldest part of Earth's atmosphere with temperatures usually -130 degrees Fahrenheit, or -90 degrees Celsius. Phew, that's enough to even send the yetis running. Above that is the Thermosphere, which extends about 56 miles, or 90 kilometers, to between 310 and 620 miles, or 501,000 kilometers, from the surface. temperatures can become 2,700 degrees Fahrenheit, or 1,500 degrees Celsius, at this altitude, a nearly complete contrast from the Mesosphere. It's considered to be in the atmosphere, but the air density is so low that most of the layer is usually thought of as outer space. In fact, our space shuttles actually remain here rather than outside the atmosphere, and this is also the layer responsible for seeing the wonderful auroras, Aurora Borealis, in the north, and Aurora Australis, in the south. After that is the exosphere, which is nothing special because it's simply just a thin layer marking the end of the atmosphere. Since we did encounter talking about aurorae, it's time for a short lesson about it. Both the northern and southern lights, known as aurorae, occurs in the thermosphere, and occurs when charged particles from the sun's solar wind strikes atoms and molecules in the atmosphere. This, in the end, results in that beautiful scene we see at the end of LEGO Frozen Northern Lights. Most people think that the aurorae are identical, since the lights follow the symmetric magnetic field emitted by the Earth. Yet a study done in Norway tells that sharper, brighter spots can be seen in the aurorae by dawn in the northern hemisphere during summer, which might be as to while last year, in Texas, during the summer, I saw the northern lights one time even though I'm about 10 tacos closer to the equator than I am to the Arctic Circle. Meanwhile, the southern hemisphere actually has its aurorae most visible in the winter during dusk. Even so, the difference is so small, it's barely noticeable. Don't tell the southern hemisphere this, but I think the northern hemisphere has much better aurorae. That is, only because I'd prefer to be up at dawn during the summer to watch this or even up in the middle of the night during the winter freezing my tushy off just to see the aurorae. Anyways, back to our lesson about the atmosphere. About 68 miles up, or 110 kilometers from the surface, which is in the lower part of the thermosphere, the Kármán line exists, which is just an imaginary line in which most scientists say is where the Earth's atmosphere meets outer space. Finally, considering that we have gone through every single part of the Earth's atmosphere, we can get back to our question, why in the world is the sky blue? Well, I already explained it to you, and I'm too lazy to go over this whole thing again. Much of the wavelengths, though, including the blue wavelength, begins to be separated furthermore in the thermosphere and scattered, having its UV rays being deflected with other unimportant wavelengths in the mesosphere and the stratosphere, especially. So, now let us get to another question, what makes a sunset? Don't worry, the explanation won't be that long. Well, it won't be that long for me, I mean, just give me another hour or so. As the Earth rotates, the sun's direct light slowly become indirect, having different colors appear in the sky when the indirect light hits where we live. The photons, which are particles of light, are scattered by molecules in the air as usual, but because of the angle the sun is hitting our planet, much more blue light is scattered, often being lost in space or spread to different parts of the planet. Therefore, light directly from the sun then appears to be red, since the reds, oranges and yellows, which have very long wavelengths, are scattered much more to where they spread across our sky, but not so much to where we can barely see it anymore, like the blues at this time. On some days, the sunset and sunrise may seem more beautiful because of how the colors spread much more descriptively and widely, having shades of yellows, reds, oranges and even magentas spread across the sky. When you see that, don't think of it to be that good because that means that there is a higher abundance of larger particles of dust, pollen, water vapor and pollution within the sky, meaning that when you see a sunrise with beautiful colors like that, it usually means that it won't be a good day for the people who have allergies. You may also want to think about bringing an umbrella tomorrow. One more thing, though. Now I know that this is almost over, but I promise, this will be quick. So, why doesn't green show up in the sunrise, sunset or daytime? Well, the answer is that it does appear within those times, it's just that it's not scattered so well fully across the sky and neither do our color receptors, in which often blends colors together, really even registers the wavelength of green in the atmosphere. Not only that, but green does appear in the atmosphere, but only within the first few seconds of the sunrise and the last few seconds of the sunset does it exist. Anyways, that's all there is to the Earth's atmosphere. Sure, there are many more descriptive parts to it, but this ultimately sums up the introductions to the Earth's atmosphere. See you next time on our next episode on One Universe News. Until then, actually do whatever you want. Well, whatever you want that happens to be legal and nice, after all. Just do all in which you want to.